How many different ways can a person travel from A to C if these are the roadways or pathways? Well, we could imagine what some of them might look like. Maybe you would start at A and take route 1, get to B, and then take route 4. So that's one of the options you could take. Another option is you could take route 2 and then route 4. But how many options are there altogether? Well, we could create a sample space for this to see what the options are, or a tree diagram. So in the first choice, you could have taken either road 1 or road 2. And having taken road 1, you could then either take road 3, 4, or 5. But also, if you had taken road 2, you could have then taken road 3, 4, or 5. And we can see when we make out a tree diagram that our options were 6 different choices. So you could have 1 and 3, 1 and 4, 1 and 5, 2 and 3, 2 and 4, and 2 and 5. There is a rule, it's called a fundamental principle of counting that we have in maths to help us with this. And the rule says when we have separate choices to make to work out the total number of options, we multiply the choices we have at each stage. So at stage 1 here we have 2 choices, and at stage 2 we have 3 choices. And according to the fundamental principle of counting, if we multiply these, we'd see that we have 6 options altogether. So that's the fundamental principle. This question is a little bit like a menu type question. From a given number of names and surnames, determine how many different surname name pairs are possible. So on the given name or first name here, we have 6 choices. So just noting that. And with the surnames, we have 5 choices. So according to the fundamental principle of counting, our number of options would be 6 times 5, which is equal to 30. So there's 30 different names you could make out of this. So you could have like Mary Mooney, Mary Byrne, Mary O'Brien, Kate McCarthy, etc. So 30 is the answer.